The whisper begins softly, as though carried across ages by winds that have never known the warmth of oceans or the scent of forests, a faint murmur rising from the quiet, dust-laden slopes of a world that has watched the universe in silence. It drifts like a tired memory, the kind that only awakens when someone is patient enough to listen, and in that gentle slowness, Mars exhales its story. Its crimson plains shimmer under the pale sunlight, stretching into a stillness so complete that even time seems to hesitate, and the whisper grows fuller, inviting you to settle deeper, to breathe slower, as though the red world itself is tucking you beneath a soft, ancient blanket woven from iron dust and dreams forgotten by Earth. The whisper moves again, curling along the horizon where the thin atmosphere paints everything in muted hues, like a watercolor left outside overnight. You can almost imagine the grains of dust rising and falling in a rhythm older than anything humanity has mapped or measured, drifting over dried riverbeds that once rippled with life's possibility. In that soft wandering, the planet seems not dead but resting, as if conserving a quiet heartbeat under its frozen crust. The whisper asks nothing from you except to let your thoughts slow until they move like silt settling in calm water, unhurried, steady, drifting downward into rest. It tells of skies tinted peach at dawn, when the sun rises small and gentle, a distant glow rather than a commanding blaze. The light spreads across dunes shaped by eons of patient winds, dunes that move in slow migrations, almost imperceptible, as though the planet is breathing in long cycles. Each grain's journey is measured not in steps or minutes but in centuries, giving the land an unhurried grace. Here, even the simplest motion becomes a lullaby, and as you imagine the landscape shifting grain by grain, it soothes the restless parts of your mind, softening them like sand warmed by morning light. The whisper glides to the memory of ancient floods that raced across plains now brittle and cracked, carving channels that snake across the surface like the veins of an old, sleeping giant. Long ago, water rushed and whispered too, murmuring through valleys where now there is only silence. The story tells how those vanished waters left behind minerals that hold faint traces of their passage, clues tucked into the soil like letters inside forgotten envelopes. Thinking of that ancient flow, now stilled, invites your own thoughts to settle, to match the pace of landscapes unchanged for millions of years. It speaks of nights so cold and clear that starlight seems to ring against the surface, each point of light sharp and unwavering. Under those stars, the planet looks almost translucent, like a fragile lantern glowing faintly in the dark. The cold carries no harsh bite in this story, only a calming stillness, a crystalline quiet that feels like a velvet curtain drawn slowly around your awareness. The whisper encourages you to imagine lying under that sky, feeling the gentle weight of the universe pressing down just enough to ease you deeper into relaxation. The whisper drifts toward the polar caps, frozen sheets that gleam softly beneath sunlight filtered by thin air. They shimmer like distant mirrors reflecting the patience of ages. Every winter, they expand with the calm assurance of a creature that knows its cycles by heart, and every spring, they retreat with equal gentleness. This rhythm, slow, dependable, unhurried, seeps into your breathing, guiding it into a steady cadence, like ice inhaling sunlight and exhaling wind over snow. It moves southward, toward volcanic mountains that tower above everything like guardians in deep meditation. Olympus Mons, the quiet colossus, stands so tall its summit may rest above the planet's thin hazes, touching sunlight before the surface does. Yet despite its size, it feels gentle, dormant, serene. Standing in its shadow in your imagination, you sense nothing fierce, only a massive stillness, like a mountain dreaming. That dreamlike presence wraps around you, encouraging your thoughts to become heavy, grounded, calm. The whisper tells of ancient lava plains, their dark basalt stretching far and wide, smoothed by time into gentle undulations. These are the old scars of a world that once pulsed with fire, now cooled into peaceful expanses where dust gathers in quiet layers. In imagining those cooled flows, it becomes easier to let your own tensions cool, to let the heat of worry dissipate until only a comfortable warmth remains, soft and steady beneath your thoughts. It slides next through canyons so vast they could cradle entire countries, yet nothing in their presence feels overwhelming. Instead, they feel like great folds in a soft, red blanket stretching across the planet, carved by forces long gone. The whisper lingers in those canyons, letting the silence echo with a deep, soothing resonance, like a distant hum that asks your mind to loosen its grip on wakefulness. Every echo feels like a gentle reminder that space exists not only around you but within you, wide and patient. It recounts the soft drift of dust storms, slow, swirling veils that sometimes sweep across the surface in lazy spirals. These storms are not violent in this gentle telling, they are more like shifting curtains, wrapping the planet in muted gold, dimming the world to a quiet dusk no matter the hour. The whisper invites you to imagine standing within that pale haze, feeling the dust settle on you like warm powder, softening every shape, every thought, until everything becomes pleasantly blurred, peaceful, hushed. The whisper carries memories of meteorites that touched the surface in distant ages, leaving behind small craters that now feel like dimples in the planet's face. Each impact once roared with energy but now rests in perfect stillness, cradling shadows throughout the long day. These quiet basins, shaped by moments of intensity long past, remind you that even the loudest events eventually fade into calm, and in thinking of them, whatever noise lingers in your mind begins to quiet, leaving space for warmth and rest. It drifts into the faint traces of past atmospheres, thicker ages when winds sculpted ridges with gentle persistence. Those layers in the soil hold records of times when the world was slightly warmer, slightly wetter, slightly more welcoming. The whisper treats these layers like pages in an ancient book being turned with care, and as it turns them, it invites you to turn away from today's concerns, letting each thought slip like a loose page, carried away by the soft Martian breeze. It moves over plains where rovers roam, their slow wheels pressing careful tracks into the dust. The whisper observes how these tiny explorers move with deliberate patience, taking their time, pausing often, as though they too are listening to the planet's quiet. Imagining their lonely, gentle journeys, you feel your own pace slow to match theirs, steady and unhurried, each moment unfolding as softly as the next. The whisper lingers on the soundless rising of the sun on Mars, a sunrise that spills gold through thin skies like a quiet promise. The day brightens with a softness Earth rarely knows, a delicate spreading of light rather than a burst. That slow illumination mirrors the gentle unfurling of calm inside you, as though your thoughts are waking inside a warm cocoon of light that expects nothing and rushes nowhere. It drifts to the small shadows cast by rocks, shadows elongated by the distant sun. These shapes stretch across the land with elegant slowness, shifting only fractionally as the hours drift by. There is something soothing in their long stillness, like the unmoving silhouette of a sleeping companion. The whisper gently encourages you to imagine lying beside those shadows, watching them inch along with a pace so slow it feels perfect for rest. It murmurs about the thin winds that skim the surface, winds so light they barely carry sound. They slide across the dust like fingers brushing a soft fabric, lifting grains here and there in slow, swirling spirals. These movements resemble thoughts drifting across a quiet mind, forming brief shapes before settling again, reminding you that it is natural for thoughts to rise and fall gently as you sink deeper into calm. The whisper moves toward the faint glow of Phobos and Deimos, tiny moons drifting across the sky like two shy companions following you through a dim corridor. Their movement is slow, almost hesitant, and their pale light softens the darkness without piercing it. Imagining them gliding overhead, you feel that same gentle companionship, a sense of being watched over by patient guardians who ask nothing but that you rest. It recalls the soft crunch of dust beneath the imagined foot, a sound so muted it barely disturbs the air. Even the idea of walking on Mars feels slow and floaty, each step cushioned by the lighter gravity. The whisper invites you to imagine moving this way, lightly, as though every step takes you deeper into softness, deeper into restfulness, deeper into a world where fatigue melts into the sand like melting frost at dawn. The whisper speaks of the rust-colored stones scattered everywhere, each one smoothed by ages of wind, shaped into gentle curves and softened edges. These stones seem to hum with the patience of a world that has waited billions of years for someone to hear its quiet stories. As you imagine touching one of these stones, your mind mimics its stillness, settling into a shape that feels easy, natural, calm. It moves into memories the planet might hold of sky-blue lakes long gone, of storms that once swept with thunder, of nights warmer than they are now. Yet even these memories are told softly, as though wrapped in delicate silk. The whisper encourages you to imagine those times not as losses but as faint echoes of warmth, gentle enough to soothe, promising that even forgotten warmth can still bring comfort. And finally, the whisper returns to the present moment, reminding you that Mars is still there, quiet, steady, unchanging in its slow rhythms. It rests in the vastness of space like a tired storyteller curling up after finishing a tale. The whisper settles beside you, becoming slower, softer, almost a breath now, inviting you to drift where thoughts loosen and rest begins, letting the red world guide you toward a sleep as ancient and peaceful as its own endless, silent dusk. In the hush of Martian dawn, the story of the old lakes unfolds like a gentle ripple across a once liquid world, a world that remembers water the way a dream remembers warmth even after waking. The remnants of ancient shorelines lie faintly etched into the red soil, curving like sleepy smiles along the rims of forgotten basins. When you let your mind drift slowly across these ghostly outlines, you can almost hear the soft lap of waves that haven't existed for billions of years, their rhythm patient and soothing, as if the planet is whispering its memories through the stillness of time. Each curve tells of a moment when Mars cradled blue in its arms, and as you imagine those waters settling under a peach-colored sky, your own thoughts find a place to settle too. The clues are delicate, soft as dust on a windowsill, and they rest quietly in mineral layers that carry the faintest echoes of lakes that once glimmered gently under a distant Sunday. These minerals formed only where water lingered for far longer than a fleeting rainfall, where whole ages passed with liquid resting calmly on the land. Clay and sulfate deposits lie like careful notes left behind by a world that didn't want its story to vanish entirely. In thinking of these minerals, born from slow chemical conversations between stone and water, you feel your own mind slow to match that pace, patient, unhurried, content to absorb the quiet truth hidden in the soil. The whisper of old lakes leads you to the idea of ancient deltas, fans of sediment spread gently across the ground where rivers once paused, catching their breath before joining broader waters. These deltas hold patterns shaped by time and softness, arranged in layers that speak of calm, persistent flow. Imagining them now, frozen into reddish stone, feels like tracing the outline of a sleeping creature's long dreams. You picture the sediments settling grain by grain, drifting downward through still water, forming beds as soft and orderly as stacked blankets folded with care. That same slow downward drift begins to anchor your thoughts, letting them sink peacefully. These lake beds, once alive with subtle motion, now lie quiet beneath the thin atmosphere, holding the memory of currents that once stirred them with delicate swirls. Even though the water is long gone, its traces linger in rippled textures preserved in stone, faint as breaths on glass. Running your imagination along these fossil ripples is like touching a lullaby carved into the surface, a record of motions that soothed the land long before any eye could witness them. Thinking of these ripples, still and perfect, draws your attention inward, to the gentle rhythms of your own breathing, steady as ancient waves. As the story deepens, the old lakes reveal signs that they once endured for ages, not fleeting moments, a startling idea for a planet now so dry. For water to have stayed so long, the climate must have been gentle enough, warm enough, balanced enough to cradle entire cycles of evaporation and return. That thought carries a softness within it, a reminder that even harsh worlds once knew tenderness. Imagining Mars under a sky that supported lakes for millions of years allows you to picture time stretching long and smooth, a time without rush or pressure, a time that mirrors the quiet stretch your mind takes as it unwinds. The clues invite you next into the notion that these lakes weren't just still pools but places where chemical dances slowly unfolded, where elements mingled in warm companionship. The water may have carried nutrients and energy, weaving together potential threads of life. Thinking of these slow, ancient interactions feels like watching small sparks drift lazily in the air, glowing softly before disappearing into the dusk. The planet seems to murmur that life's simplest beginnings often require the calmest settings, and that idea wraps around you like a gentle reassurance that stillness can be fertile and meaningful. As the whisper drifts along dried shorelines, it points to sediment layers stacked like quiet stories, each layer a page capturing a different mood of the ancient lake. Some layers are fine as powdered cinnamon, others coarse like crushed shells, though no shells ever existed here. Each layer settled over long, slow spans of time, building a quiet archive beneath the water's surface. Imagining these layers building themselves grain by grain brings a sense of stability, like watching someone place soft blankets over a weary traveler, each one adding a little more comfort, a little more warmth. The whisper of clues leads you to the strange beauty of carbonate minerals rare on the Martian surface, shy in their appearance, yet so meaningful. Carbonates form only when water and atmosphere blend in harmony, capturing whispers of ancient air within crystal structures. These rocks carry memories not just of water but of the climate that nurtured it. Thinking of crystals forming so slowly, over countless years, encourages your thoughts to drift like slow-moving clouds across the mind, dissolving stress and leaving only ease. The old lakes reveal their edges in the shapes of ancient beaches, gently sloping terraces that look as if the water simply stepped backward over time, leaving behind footprints of its retreat. These terraces hold the softness of long, lazy rhythms of rising and receding. As you picture these shorelines, you can almost hear the quiet shuffle of water drawing away in tiny increments, its absence leaving delicate curves in the land. This imagined sound is calming, like a tide that withdraws without urgency, guiding your thoughts into a similarly slow, smooth rhythm. Near these ancient beaches lie boulders smoothed by waves that haven't touched them in ages. Their rounded forms tell of patient polishing, as if time itself had taken these stones gently in hand, shaping them through the persistence of liquid touch. Holding that image in your mind, a stone softened over eons by gentle water helps soften the harder corners of your own awareness. The world seems to exhale, and with it, so do you, sinking a little deeper into quiet. The whisper moves into deeper waters, drifting through memories of thick sediments at the bottoms of the ancient lakes, where organic molecules may once have gathered like shy guests at a peaceful gathering. These molecules, though simple, represent possibility, traces of chemistry that might have nudged toward life. Imagining them suspended in calm water, drifting slowly like particles caught in a sunbeam, brings a feeling of weightlessness, as though your thoughts themselves float freely, untethered and serene. Some of the most evocative clues come from the shapes of ancient river channels that fed into the lakes, branching like delicate veins across the land. Their paths are gentle, curving with the natural ease of water that flowed for long stretches of time. Following their shapes in your imagination feels like tracing the soft lines of a map meant for dreaming rather than navigation. Each branch leads you somewhere softer, quieter, encouraging your mind to wander freely without intention. The story lingers on the calmness of Mars' once thicker atmosphere, which must have wrapped the lakes in a blanket, slowing evaporation and nurturing a more Earth-like world. Imagining this thicker air, warm enough to allow water to rest, creates a sense of shelter, as though the planet itself once knew how to cradle comfort. In letting this atmosphere drift into your thoughts, you feel a similar cocoon forming around your mind, shielding you from the sharp edges of wakefulness. Near the edges of the ancient lakes, rocks cracked by long cycles of freezing and thawing lie scattered like gentle reminders that the planet once had weather soft enough to melt ice, warm enough to let water gather, cool enough to let frost settle. This slow cycle feels soothing, a rhythm of warming and cooling like the rise and fall of breath. Imagining these cycles continuing patiently over ages helps align your own breathing to a gentle, natural pattern. The old lakes also reveal their secrets through the presence of rounded pebbles that could only have been shaped by flowing water, pebbles that once clinked softly together beneath gentle waves. Thinking of their soft, muted collisions, water-carved, rhythmically polished, creates a kind of internal lullaby, a clinking that exists not as sound but as feeling, guiding your awareness toward sleep as surely as stones sink beneath the surface. The whisper touches on the idea that some lakes may have frozen over at times, trapping liquid water beneath thick, protective ice, a serene environment shielded from harsh winds. Imagining such sub-ice lakes, glowing softly in dim light, feels like peering into a hidden world where warmth and quiet coexist. This hidden warmth mirrors the small, glowing calm inside you that persists even in moments of cold or stress, a reminder of inner stillness that cannot be extinguished. The clues extend to the soft layering of mudstones, rocks that only form when fine sediments settle slowly in calm water. These mudstones hold delicate patterns, like faint fingerprints of ancient tranquility. Imagining these fine sediments drifting downward, each particle floating gently before coming to rest, invites your thoughts to drift in the same slow descent, settling comfortably, naturally, without effort. The story moves to hints of salts left behind when the lakes evaporated completely, forming bright, powdery rings along the old shorelines. These salt deposits shimmer faintly, like frost left from a forgotten dawn. Thinking of them glinting softly under thin sunlight brings a sense of quiet brightness, a light that doesn't disturb but instead soothes, the kind that fills spaces gently like dawn glowing behind closed eyelids. The whisper slips softly into the idea of groundwater that once seeped into these lakes, feeding them from below like a hidden heartbeat. This steady, unseen flow kept the lakes alive even when surface conditions grew harsh. Imagining this secret movement feels comforting, a reminder that not all support is visible, that quiet strength exists beneath the surface of both planets and people. That hidden pulse echoes subtly within you, guiding you toward deeper rest. Near the dried edges of the lakes lie minerals that once formed in hot springs, warm, gentle waters rising from below, mixing with cooler lakes above. These hot springs might have been among the warmest, most life-friendly places on early Mars. Imagining warm water rising slowly from deep beneath the crust evokes a sense of rising calm within you, like warmth spreading through tired limbs, easing tension with subtle, steady comfort. The whisper turns toward the possibility that some lakes may have remained stable for millions of years, enduring through shifting climates and long seasons of change. Their persistence gives a sense of resilience, a quiet strength that doesn't roar or demand attention but simply holds steady. Thinking of such long-lasting calm allows your mind to adopt the same quiet endurance, easing into a stillness that feels timeless. Finally, the old lakes offer one last clue, not in what remains, but in how gently time has preserved their shapes. They lie like soft impressions pressed into the planet's memory, undisturbed by all the years that have passed. Imagining these impressions, untouched by haste or noise, encourages your awareness to slip into the same preserved quiet, settling gently into the soft, wide silence that Mars has known for billions of years, inviting you into rest as ancient and peaceful as the planet's own deep, red calm. The language of organics begins not with sound but with a gentle presence, a quiet hum woven into the dust and stone of Mars, like a message written in a script the universe formed before any mind could read. These organic molecules, simple yet undeniably meaningful, rest in the soil like soft echoes of chemistry that once unfolded under calmer skies. They are not alive, not voices of vanished beings, but patterns, subtle arrangements of carbon that whisper of possibility. Letting your thoughts drift around these molecules feels like brushing your fingers along the surface of an ancient book, its pages warm, its meaning patient, waiting for someone to listen without rushing. These organics lie scattered in tiny grains, preserved in minerals that shield them from the harsh radiation that sweeps across the Martian surface. Their preservation feels almost tender, like an instinctive gesture of protection made by the planet itself. Imagining these small molecules tucked safely within rock brings a sense of comfort, like something fragile being held gently in cupped hands. The chemistry that formed them stretched across long, slow ages where time moved not in hours but in geological breaths, and as you imagine that slowness, your own thoughts soften to match the pace of something ancient and unhurried. The whisper of these molecules traces back to moments when energy passed through the soil, perhaps sparked by volcanic heat or sunlight filtering through a thicker sky. Those reactions, quiet and persistent, created chains of carbon that linger still, subtle signatures left behind like faint footprints in sand. Thinking of these reactions unfolding over centuries feels like listening to a soft, steady rhythm, a heartbeat of chemistry that continues in memory alone. Your mind relaxes into that slow, steady pulse, mirroring the unhurried pace of the planet's own forgotten processes. In some places, organics are found deep within layers of sediment that settled long ago when lakes pooled across the surface. These layers formed gently, allowing molecules drifting in the water to sink slowly and become part of the lake bed. Imagining these molecules floating downward like tiny sparks drifting to rest at the bottom of a calm pond encourages your thoughts to drift as well, settling smoothly, comfortably, without resistance. The quiet descent of ancient organics becomes a lullaby of slow motion, coaxing your awareness into a softer space. The molecules themselves are modest, simple carbon chains, aromatic rings, small fragments of chemistry that on Earth often appear where life has brushed past. Yet on Mars they whisper not of certainty but of possibilities, possibilities that linger softly around. The edges of imagination. Thinking about these possible meanings feels like standing at the threshold of a dimly lit room, sensing warmth within without needing to step inside. This gentle uncertainty, far from unsettling, becomes soothing, because it holds no urgency, only quiet wonder. Some organics may have formed through interactions between water and rock deep beneath the surface, where warmth lingered even as the world above cooled. In those hidden places, hydrogen and carbon could combine slowly in darkness, shaping molecules that would eventually ride upward through cracks, settling into the soil. Imagining this secret chemistry unfolding in calm subterranean chambers feels like imagining a hidden sanctuary, warm, safe, undisturbed. That sense of hidden warmth spreads through your thoughts, creating an inner quiet where nothing disturbs your rest. Other organics might have arrived from beyond Mars, carried by meteorites that gently delivered carbon-rich fragments from the ancient solar system. These cosmic visitors brought their own quiet stories, stories formed in cold interstellar clouds long before the planets existed. Imagining these fragments drifting through space for millions of years before settling softly on the red surface feels like watching snowflakes fall in slow motion across an endless dark sky. Their long, peaceful journey invites your awareness into a similar drifting calm, weightless and serene. The whisper of organics grows stronger in the clay-rich regions, places that once held water long enough for life-friendly chemistry to linger. Clays protect molecules the way soft earth protects seeds, holding them gently for eons. Imagining organics nested inside these clays feels like picturing tiny messages wrapped in soft blankets, preserved with care through storms of time. As you picture these sheltered molecules, a similar feeling of being held safely settles over your thoughts, easing your mind deeper into rest. Some organic fragments show signs of being altered by radiation over billions of years, their structures slightly changed, reshaped by the slow touch of cosmic energy. These altered molecules feel like faded letters, still meaningful, still gentle, even if changed. Imagining these faded signatures brings the same feeling as recalling a memory softened by time, one that no longer carries weight but only quiet, distant warmth. That softened feeling helps untangle the tightness of wakefulness, letting your thoughts loosen like threads in a gently unraveling weave. The presence of sulfur in some organic-rich rocks suggests that the organics interacted with volcanic gases long ago, forming compounds with their own subtle complexity. This mixture of elements creates a sense of layered history, like a soft harmony of notes blending slowly over ages. Imagining these quiet chemical harmonies makes your awareness feel like it is drifting through a slow, gentle melody, never loud, never sharp, but soothing in its patient complexity. In other regions, organics appear alongside perchlorates, chemicals that on the surface might break them down but deep within the soil may have helped preserve them. This paradox, destructive above, protective below, adds a softness to the story, reminding you that even harsh things can hold gentle possibilities in the right places. Imagining these layers feels like sinking through blankets, the outer ones rough, the inner layers soft and warm. As your thoughts drift deeper, the outer noise fades and only the inner comfort remains. Some organic molecules found on Mars resemble those formed in deep space ice when exposed to ultraviolet light, simple, primordial patterns that existed long before planets cooled. Imagining such ancient chemistry settling on Mars feels like imagining the universe whispering through dust, leaving soft traces of its earliest stories. As you picture these cosmic stories drifting down, your thoughts open to that same vast stillness, a quiet space where time stretches comfortably and your awareness can rest. The language of these molecules is patient. They do not demand interpretation, they simply exist, like quiet markings on stone, waiting for minds to become calm enough to read them. Imagining this patience feels like sitting beside a calm companion who speaks rarely but always in gentle tones. That imagined companionship wraps around you, easing the spaces where tension hides, inviting you into a deeper, quieter listening. In some places, these organics appear in alternating bands, each band representing a different era of deposition. This layered arrangement feels like a slow, measured heartbeat, a rhythm that spans ages. Imagining these layers, each one laid down softly like a thin sheet of silk, guides your thoughts toward a similar rhythm. Each breath becomes a layer, each moment another soft sheet settling gently over your awareness. The whisper of organics leads you next to the idea that Mars once had pockets of warmth where ice melted and refroze in long cycles, creating environments where carbon chemistry could linger. These cycles feel like a long, slow rocking motion, warmth rising, cooling returning, steady and predictable. Imagining this planetary rocking brings its own quiet sway to your mind, a gentle rocking that lulls you deeper into stillness. Some organics form through photochemical reactions in the atmosphere, drifting downward like soft snow, settling across the land in a thin, invisible layer. Imagining these molecules falling slowly through the pink sky feels like watching tiny feathers drifting downward, weightless and calm. As they settle, your own thoughts settle with them, floating softly downward into a space of quiet ease. The organics discovered by rovers often lie in fractured rocks, where time and pressure gently exposed their hidden interiors. These fractures feel like delicate seams where the planet has opened just enough to reveal its secrets, but not enough to disturb its deep stillness. Imagining these fragile openings feels like peeking into the quiet interior of something long asleep, careful not to wake it. Your own awareness mirrors this caution, softening further, moving gently. The molecules also appear in regions where groundwater once rose and fell, carrying organics with it in slow, wandering currents. This movement feels like a whispering tide beneath the surface, invisible but steady. Imagining this hidden tide feels like sensing a calm wave passing beneath you, lifting you gently before lowering you again, smoothing away any restless thoughts as it flows. Some organics appear burned or altered by ancient volcanic events, their structures changed but their presence preserved in the ash. These altered molecules feel like gentle survivors of long-ago warmth, holding on through heat and cooling to rest where they now lie. Imagining these quiet survivors makes your awareness feel resilient yet soft, able to let go of tension while keeping a gentle center of calm. Rovers often heat the soil to release organics, and the warmth required echoes the warmth that once flowed naturally through the planet. Imagining that warmth spreading through the soil, releasing whispers of long-held secrets, creates a sensation of warmth spreading through your own thoughts. It relaxes tension, melts stiffness, and opens a path toward rest, slow and soothing. Some organics appear in dark, quiet dunes where the wind drifts slowly across the surface. These dunes move in slow, patient migrations across the land, carrying carbon with them grain by grain. Imagining these dunes moving like slow, breathing giants creates a sense of gentle motion that rocks your awareness toward deeper calm, a movement so gradual it feels like stillness. The language of organics on Mars is a language without urgency, spoken in faint traces left across billions of years. It is a language of waiting, of persistence, of quiet presence. Imagining this slow, unbroken patience invites your thoughts to spread out like a calm horizon, wide and restful, with nothing pressing forward. And in the final whisper, the organics remind you that Mars, though quiet now, carries the soft memories of chemistry that once stirred gently under warmer skies. These molecules lie like lullabies preserved in stone, waiting for the quiet moments when someone listens. And as you listen in the hush of this story, your thoughts drift downward into the same stillness that cradles these ancient traces, guiding you softly into a deep, peaceful calm. Methane on Mars arrives not as a shout but as a soft, fleeting note that rises into the thin air and fades before anyone can be sure what it meant. It is a gentle, wavering signal, so brief and delicate that it feels almost like a sigh carried on the cold winds. Scientists measure it carefully, finding only a small hint here, a whisper there, as if the planet is speaking in a language made of vanishing breaths. Thinking about this quiet appearance of methane feels like watching a candle flicker from far away, uncertain but calming in its faint glow, inviting you to lean closer while your thoughts drift into its softness. The methane seems to appear unpredictably, only to dissolve under sunlight or disperse into silence, leaving behind questions that rest lightly on the mind. Its presence feels less like a clue and more like a gentle nudge, a reminder that Mars still holds subtle rhythms beneath its still surface. This uncertainty carries its own calming quality, because nothing is rushed, nothing is forced. Imagining methane rising slowly into the cold atmosphere, only to thin out again, lulls your awareness into an easy ebb and flow, the rhythm of something appearing and disappearing without urgency. Some of this methane may originate from the deep crust, moving upward through fractures in the rock created over eons by cooling, shifting, and quiet settling. These fractures act like narrow breaths within the planet, channels through which small quantities of gas find their way upward. Imagining this upward journey feels like picturing a slow exhale from deep within the planet, a warm breath escaping from ancient stone. That soft, slow rising brings a sense of calm to your own breathing, aligning it with the planet's quiet pulse. Other methane might be released when sunlight warms certain minerals near the surface, coaxing them gently to release gases trapped long ago. This warming is gradual, soft as dawn light creeping across a sleeping landscape. Imagining these trapped molecules awakening under gentle warmth feels like watching frost melt in slow motion, revealing faint details beneath. That slow revealing invites your thoughts to melt, letting tension dissolve the way frost retreats from warm stone. In some places, methane may be produced through interactions between rock and water deep below, in dark, hidden pockets where warmth and chemistry linger. These reactions unfold quietly, with no dramatic spark, only the patient meeting of elements through time. Imagining this hidden chemistry feels like picturing a small lantern glowing in a vast cavern, steady, faint, comforting. That imagined glow settles in your mind, softening the edges of wakefulness and guiding your thoughts toward rest. The methane could also be ancient, left over from times when Mars was warmer and wetter. If so, each detection is like hearing an echo from a long-forgotten age, a note carried across billions of years. Imagining this ancient echo drifting slowly upward through dust and stone feels like hearing the soft hum of a faraway memory, gentle, soothing, without urgency. This echo wraps around your thoughts, encouraging them to quiet themselves, to rest in the soft presence of something old and patient. Methane sometimes spikes in concentration during certain seasons, as though the planet exhales more deeply at specific moments in its long year. These seasonal breaths feel like the slow inhalations and exhalations of a sleeping body, steady and calming. Thinking about this rhythmic release aligns your mind with that slow planetary breathing, inviting your thoughts to rise and fall like a soft tide within you. It becomes a shared rhythm, quiet and grounding. When rovers detect methane, the signals are faint, delicate blips against the background of the thin air. These blips feel like tiny lights blinking gently in a dim room, offering a momentary glow. Imagining these faint signals appearing against the vast quiet of the Martian atmosphere fills your mind with the sense of stillness that envelopes them, a stillness so deep it feels like a cushion of silence where your thoughts can sink slowly and peacefully. Methane is fragile under sunlight, breaking apart within months when exposed to the harsh radiation. This fragility makes each detection feel even softer, like a snowflake landing before melting. Imagining methane breaking apart gently under sunlight, dissolving into harmless fragments, feels like watching a soap bubble drift upward until it pops silently. That gentle dissolution mirrors the way alertness begins to fade, dissolving into calm. Some methane may be trapped in crystalline structures known as clathrates, frozen cages that hold gases securely until warmth loosens them. Imagining these icy cages beneath the Martian soil, holding their tiny treasures through long ages of cold, feels like picturing small chests of preserved breath hidden in a frozen dream. When they release their gas, it emerges softly, quietly, like the faint sigh of ice shifting. That imagined sigh encourages your mind to relax deeper, surrendering tension like ice surrendering its grip. The methane, when mapped, forms patches rather than wide blankets across the planet. These patches feel like small notes scattered across a quiet musical score, each appearing briefly before fading. Imagining these scattered notes floating upward into the sky creates a sense of calm, as if the planet is humming a gentle, disjointed lullaby. This subtle tune invites your thoughts to move slowly, drifting without direction toward deeper serenity. Some detections of methane differ between rovers and orbiters, a mystery that feels like two gentle voices hearing slightly different parts of the same soft song. This mismatch doesn't disturb, instead, it adds to the dreamlike quality of methane's presence. Imagining these two perspectives, one close to the ground, one far above, feels like watching two waves ripple through the same pond from different angles. The overlapping ripples create a soothing pattern, calming your thoughts with their gentle motion. Methane's occasional song is so faint that scientists must listen with exquisite stillness, much like someone leaning in to hear a whisper in a quiet room. Imagining this careful listening feels like a peaceful moment where everything slows, where attention becomes soft and steady. This imagined stillness offers your own mind a gentle space to rest, easing away the clutter of noise and thought. In some places, sunlight warms the soil just enough to release small bursts of methane, like brief exhalations. Imagining these small releases rising through the thin air feels like watching tiny bubbles float slowly upward in clear water. Their rise is gentle, steady, unhurried, a motion that invites your awareness to float upward with them before settling again into quiet. Even the absence of methane is part of its soft story, the long stretches where no signal appears, where the air shows nothing but silence. This silence feels comforting, like a long pause in a lullaby, a space where you can breathe deeply and let go. Imagining this silence spreading across the planet's wide plains brings a sense of open calm, a vastness that gently absorbs all urgency. The methane that does appear may interact with dust, becoming part of the soft haze that drifts across the planet. Imagining methane mixing gently with dust particles feels like imagining small notes dissolving into a quiet background hum. That hum is soothing, something felt rather than heard, guiding your thoughts into comfortable stillness. Some scientists consider whether tiny subsurface microbes could produce methane, though no evidence yet confirms such life. Still, the idea adds a gentle curiosity, a soft wondering rather than a demand for answers. Imagining this possibility feels like seeing a small light glowing faintly beneath the ground, not bright enough to disturb the darkness but warm enough to comfort. That warmth settles in your awareness, easing it further toward rest. Mars' cold nights help methane linger longer near the surface, allowing brief pockets of gas to gather before dawn light breaks them apart. Imagining these pockets resting quietly in the frigid air feels like picturing soft breath clouds hanging momentarily in the cold before dissolving. This temporary stillness mirrors the pause between breaths, calming and natural, guiding you into deeper quiet. The thin atmosphere spreads methane quickly, smoothing out its presence until only the faintest trace remains. Imagining this soft spreading feels like watching fog drift across still water, thinning gradually until it becomes part of the air itself. Your thoughts drift with that fog, becoming lighter, slower, gentler with each moment. Methane's story on Mars is not one of certainty but of softness, brief appearances, gentle hints, unanswered questions. Its uncertainty is not unsettling. Instead, it feels like a dream half remembered, its meaning less important than its quiet presence. Imagining this dreamlike quality allows your awareness to move freely, without expectation, into a deeper calm. The gas may sink into the soil again, becoming part of the hidden world beneath the surface. Imagining it settling downward feels like picturing grains of sand sliding quietly into place, forming smooth layers beneath your feet. This downward motion encourages your own thoughts to settle, gently, into the quiet spaces within you. Sometimes, methane seems to rise during the warm midday hours, as if the planet is exhaling under the sun's touch. Imagining this warm exhale brings a sense of heat spreading slowly across the land, comforting and soft. Your own awareness warms with it, releasing tension the way warmed soil releases gas. And in the final whisper, methane's soft, occasional song reminds you that Mars is not silent but subtly alive with chemical murmurs. These faint, drifting notes tell a story not of loud activity but of deep, ancient processes that continue in gentle rhythms. As you listen to this quiet song, your thoughts fall into step with its softness, drifting slowly downward into a peaceful, patient stillness where rest arrives as naturally as breath. In the gentle hush of Martian twilight, when the last traces of sunlight glide across the dusty plains like fading memories, the rocks begin to feel less like objects and more like quiet archivists of an ancient world. Each one holds layers upon layers of time, pressed together so patiently that even the softest whisper of wind seems hesitant to disturb them. As you look across those scattered stones, some jagged like broken thoughts, others rounded like ideas polished by ages, you sense that they are waiting, not to be claimed, but to be understood. Their stillness is not emptiness, it is a long-held breath, carrying hints of rivers, volcanoes, and drifting sands from ages that no human ever watched unfold. When scientists first reached out to these rocks with instruments instead of hands, they felt as though they were turning delicate pages in a cosmic diary. Some fragments contained minerals that could only form in water, suggesting that Mars once wrapped its surface in gentle streams and calm lakes. Others carried textures shaped by wind alone, telling of dry seasons that stretched so far they became eras. Each sample deepened the quiet truth that Mars didn't simply change, it endured, adapting through cold, dryness, and loss. To touch these rocks, even from millions of miles away, was to feel the pulse of a planet that had once been warm, vibrant, and maybe even welcoming. Many stones were cut in half to reveal bands of color: rusty reds, pale yellows, muted grays, like a slow sunset captured in cross-section. These bands were signs of different chemical dances, each layer hinting at shifts in the planet's climate. Some layers were rich with salts left behind by evaporating lakes, others were dust blown in from distant deserts during storms so large they wrapped the entire planet. Together, the patterns whispered of cycles: wet then dry, warm then cold, cycles that might have helped life emerge in brief, hopeful chapters before slipping back into silence. These stones didn't shout conclusions, they offered gentle clues, as though careful not to wake the sleeping world around them. Among these rocks were the volcanic ones, dark, solid, and heavy with the memory of fire. They formed when Mars was younger, more restless, more willing to reshape itself. Their crystals recorded cooling rates and chemical compositions that revealed the state of the Martian interior billions of years ago. Analyzing them felt like listening to the planet's heartbeat from long ago, back when magma flowed freely beneath the surface and heat radiated upward like a secret life force. Even now, though the volcanoes are silent, the rocks they once birthed still murmur of that ancient energy, preserved in their hardness and subtle sheen. Some of the most intriguing rocks were not volcanic nor sedimentary, but something in between, stones shaped by both fire and water. These carried signs that lava had once met flowing rivers, cooling rapidly into unusual textures that looked like glass and sponge combined. Such interactions spoke of a Mars that was neither wholly dry nor entirely aquatic, but shifting between states, almost undecided. Scientists interpreted these formations as hints of a world in transition, caught between warmth and ice, possibility and retreat. It made them wonder how many times Mars had almost become a world like Earth, only to drift back toward coldness before life could fully take hold. There were also rocks scarred by meteorite impacts, shocked, cracked, and fused into new shapes under unimaginable pressure. These impact stones told of collisions that changed the planet's geography in moments, carving craters deep enough to expose underground layers. By studying them, researchers could trace the violent episodes that shaped the surface, punctuating the otherwise slow evolution with chaotic punctuation marks. Yet even in their violence, these scars became windows into buried environments, some of which may have once sheltered warmth and water beneath protective layers of rock. Destruction, in a strange way, revealed hidden stories. One category of rocks fascinated scientists the most: the clay-bearing ones. On Earth, clays often form when minerals interact with long-lasting water gentle enough to cradle life. Finding clays on Mars felt like uncovering pages that had been carefully written in soft ink, still intact despite their age. These clays held chemical signatures that suggested neutral pH levels and mild temperatures, conditions that many simple life forms could have endured. Each clay sample was a soft-spoken affirmation that Mars had once held environments that were not harsh or forbidding, but patient and nurturing. Other rocks showed traces of ancient hydrothermal systems, regions where heated water once surged through fractures, bringing minerals along pathways like veins in a sleeping creature. Hydrothermal environments on Earth are known to shelter resilient microbial organisms, thriving in warmth and mineral-rich shadows. When Mars revealed similar formations, it felt like the planet was admitting that beneath its cold exterior, it once hosted pockets of energy and chemistry that could have sparked life's earliest conversations. These rocks were like quiet nods to the idea that Mars was never truly barren, just aging and cooling. Some Martian stones even carried spherules, tiny rounded formations shaped by either water or volcanic activity. Holding on to their smoothness, even through robotic hands, scientists felt as though they were examining beads left behind by the rhythm of ancient processes. The spherules hinted at repeated interactions with liquid, rolling and settling until they found their final shapes. They felt like pebbles from forgotten shores, each one hinting at the gentle lapping of water that had vanished long before any observer arrived. The layered sedimentary rocks in crater walls were like towering bookshelves carved by time. Each layer represented not a year or a century but vast epochs. The deeper layers were older, holding the earliest chapters of Martian history. By tracing the subtle differences between each stratum, researchers pieced together the planet's climatic shifts, periods of lake fullness, drought-like dryness, dusty winds, and temporary warmth. These rocks painted Mars as a world that didn't simply decline into coldness but fluctuated, trying repeatedly to hold on to its warmth. In some regions, rocks bore polygonal patterns etched across broad plains, marks left by cycles of freezing and thawing. On Earth, similar patterns appear in permafrost regions, hinting at moisture locked beneath the surface. To see such shapes on Mars was to imagine a world where the soil once expanded and contracted with the seasons, breathing slowly like a creature resting under a blanket of frost. These rocks didn't just tell of water that once flowed, they suggested water that lingered, froze, melted, and persisted through long, quiet ages. A few stones held mineral veins, thin, pale lines cutting through darker rock, formed when liquid seeped into cracks and later hardened. These veins were astonishingly informative because the minerals inside them often formed at very specific temperatures and conditions. To find such veins meant discovering direct evidence that water had moved through these rocks after they formed, long enough for the liquid to leave behind its mineral memory. It hinted at a Mars that had groundwater moving through its crust like soft, hidden arteries. Several rocks showed signs of having been weathered chemically, as if the atmosphere itself had once interacted with them in a more dynamic way. Certain minerals only form when water vapor and gases regularly touch exposed surfaces, slowly reshaping them. These traces suggested that Mars' atmosphere was once thicker, with cycles of moisture that allowed rocks to breathe in and out over millennia. It created the sense that the planet had not always been still and silent, but once had skies that changed and interacted with the ground below. Silica-rich rocks discovered by rovers were another quiet revelation. On Earth, high concentrations of silica can form through either volcanic steam or the slow dissolution of minerals in hot water, both environments known to shelter life. Examining these Martian silica deposits felt like examining the ashes of ancient conditions capable of supporting life. Their pale, almost ghostly appearance made them seem like the remains of vanished warmth, preserved like delicate fossils of an environment rather than organisms themselves. Some stones carried magnetic properties that differed from others nearby, suggesting that the planet once had a magnetic field strong enough to imprint itself on forming rocks. As the magnetic minerals cooled, they locked in the direction and intensity of the ancient field. By analyzing this imprint, scientists learned that early Mars had a protective magnetic shield, one strong enough to guard against solar winds. This discovery made the rocks feel like tiny compasses pointing back to a time when the planet was shielded, warmer, and more capable of keeping its atmosphere intact. Rocks collected from crater floors often showed mixtures of materials brought together by ancient floods. These conglomerates, stones cemented together by minerals, were clear signs that powerful water once rushed through valleys and basins, carrying debris and depositing them in new formations. The rounded shapes of some pebbles meant they had tumbled long distances, smoothed by water just as river stones on Earth are. Each conglomerate felt like a time capsule of a riverbed, locked in place since the water receded billions of years ago. Other stones contained traces of perchlorates, chemicals that can form naturally in cold, dry environments. While perchlorates themselves are harsh and reactive, their presence pointed to a planet that had undergone complex chemical cycles over long stretches of time. They hinted that the Martian surface had been shaped by not only water but also atmospheric processes that created layered chemical stories in the soil and rocks. Even in their harshness, these compounds suggested diversity rather than emptiness. One rock discovered by a rover was so unusual in shape and composition that it seemed almost out of place, a metallic-looking fragment, smoother and stronger than surrounding stones. It turned out to be a meteorite, having survived its fiery plunge through the thin Martian atmosphere. This meteorite was a traveler from another world, carrying its own separate history. Its presence reminded scientists that Mars had always been part of a wider cosmic conversation, exchanging material with space just as Earth does. Some stones glimmered faintly when struck by light, signs of crystalline minerals arranged in precise structures. These minerals only form when conditions remain stable for long periods, allowing atoms to settle into their most orderly arrangements. Their quiet shimmer felt like the planet's way of revealing that, even in tumultuous climates, there were moments of calm that lasted long enough for beauty to crystallize out of dust and heat. Rocks in the ancient delta regions were particularly treasured because they formed where water once slowed and spread, allowing sediments to settle gently. These rocks were layered delicately, like pages written with careful strokes. Deltas on Earth are fertile, biologically rich environments, and though no life was found in the Martian rocks, the architecture of their layers suggested that these places would have been among the most hospitable. Each grain was a note in a long-lost lullaby of flowing water. Many rocks near the edges of dried lake beds contained evaporite minerals, salts left behind when water vanished. These salts were fragile, prone to breakdown, yet somehow they persisted through ages of wind and temperature swings. Their survival felt like a small miracle, giving clues about the chemistry of ancient Martian lakes, how salty they were, how long they lasted, how quickly they disappeared. The rocks seemed to hold the emotional arc of those lakes, their swelling, their shrinking, their gentle departure. Some rocks were so heavily coated in dust that their true identities remained hidden until brushed clean by robotic tools. Underneath the powdery red veneer, scientists often found colors and textures that contradicted the surface appearance. This contrast between exterior and interior felt symbolic of Mars itself, a planet whose quiet, dusty present disguises a varied and dynamic past. Each freshly cleaned rock revealed a little more of the world Mars used to be, as if shedding its tired cloak for a moment to show a glimpse of its younger self. The final category of rocks that drew attention were those that had fractured naturally into geometric shapes, hexagons, rectangles, and even elongated prisms. These fractures formed through slow, persistent cooling or drying, creating patterns that seemed almost purposeful. They spoke of time not in events but in endurance, in the patient shrinking of stone as it cooled or dried. These shapes made it easier to imagine Mars not as a world of chaos but as a place where natural rhythms once unfolded with quiet precision. As all these rocks were studied, catalogued, and understood, one truth became soothingly clear: Mars had lived many lives. It had been warm, wet, volcanic, frozen, battered, eroded, and reshaped countless times. Each rock was a chapter, each mineral a sentence, each layer a gentle hint that the planet had once been far more than a cold desert. Through them, Mars was not just a distant sphere in space but a storyteller, soft-spoken, patient, and willing to share its entire autobiography with anyone who approached with curiosity and care. When the rover first rolled across that lonely expanse of Martian plain, its cameras caught sight of something that didn't quite belong, an object resting so quietly in the dust that it almost seemed to be pretending to be ordinary. But even from a distance, the stone looked different. Its surface glinted not with the common matte red of iron oxide but with a muted metallic sheen, as if the light, thin as it was in the Martian atmosphere, caught on edges that shouldn't exist naturally in that landscape. The rover paused, as though gathering its mechanical breath, and turned toward it. What lay ahead was not a boulder sculpted by wind or water, but a stone that felt like a visitor from somewhere else, waiting to be noticed in the endless silence. As the rover approached, its instruments registered dense material, far denser than the volcanic rocks scattered across the plain. The shape, too, was odd, neither rounded like river stones nor angular like recently fractured rock. It had smooth curves, shallow pits, and a texture that spoke of melting and rapid cooling. It was a familiar shape to scientists, yet startling in its presence there, the unmistakable signature of a meteorite. But not just any meteorite, a metallic one, rich in iron and nickel, forged in the heart of an asteroid and sent here by ancient cosmic tumbling. To find such a guest lying so casually in the dust made the plain feel less empty, as though the universe had dropped a quiet reminder that Mars, too, is part of a greater, wandering story. Its surface bore patterns like frozen ripples, formed when the meteorite once blazed through an atmosphere thicker than Mars has now. These patterns suggested a time when the air above this planet could generate enough frictional heat to sculpt metal as it fell. That meant the rock had likely landed long ago, perhaps billions of years in the past, back when Mars still held onto more of its sky. Those faint lines were a timeline written into metal, recording a fiery entry into a world that has since changed so profoundly that such an event would look very different today. The meteorite thus became not just a foreign object but a witness, one that had felt the texture of a younger Martian atmosphere on its skin. Around the stone, the dust formed a shallow depression, shaped by slow settling rather than impact. That told scientists that the meteorite had been resting there for an incredibly long time, perhaps longer than any human could easily imagine. Winds had brushed dust around its edges, storms had swept over it, and seasons had passed in countless cycles of cold and colder. Yet the meteorite itself remained intact, its metal resisting corrosion far better than native rocks. It was as though it had simply refused to age at the same pace as its surroundings, holding on to a kind of stubborn immortality while the world around it weathered and softened. Some parts of its surface were coated with a thin layer of Martian dust that clung like a veil, muting the stone's metallic glow. But in the small regions where the dust had blown away, perhaps scraped lightly by the rover's instruments, the metal gleamed with a faint silvery-grey tone. The contrast between these patches hinted at cycles of dust deposition and removal, telling scientists how active the winds in this region might be. The meteorite became a quiet reference point in a landscape that often shifted subtly, a stationary witness to moving air, drifting particles, and the patient work of erosion that happened grain by grain rather than gust by gust. When the rover extended its spectrometer, it detected the unmistakable signatures of iron mixed with nickel, classic hallmarks of iron meteorites formed deep within the cores of differentiated asteroids. That meant this stone was once part of something big enough to melt internally, separate into layers, and then shatter under cosmic violence. To imagine that entire history condensed into a single object resting on the plain was almost dreamlike. The stone had traveled through darkness across untold distances, broken free from its parent body, wandered in orbit, and finally descended onto Mars, where it settled as quietly as if it had always been meant to land there. Closer inspection showed small cavities on the meteorite's surface, regmaglypts, or thumbprint-like depressions shaped by scorching winds during entry through an atmosphere. These tiny hollows felt almost tender, like impressions left by invisible fingers. Each one spoke of heat, speed, and pressure beyond anything Mars now experiences. Scientists realized these features could only have formed if the atmosphere at that time was denser than it is today, adding another subtle clue about the planet's long-ago past. This single stone, with its delicate pits, became a tiny fossil of aerodynamic sculpting, preserved far better than any written record ever could be. The stone's mass surprised scientists as well. Even in the weakened Martian gravity, the rover's instruments indicated it was remarkably heavy for its size. This heaviness confirmed its metallic nature and suggested that it might have remained in place through even the most intense dust storms. Where lighter stones would shift or tumble, this one stayed rooted, letting sands move around it like water around an anchored boat. In this way, it stabilized its own surroundings, creating a shelter where dust built slightly higher on the leeward side, forming miniature dunes that rose and fell with the seasons. Chemical scans revealed trace amounts of elements such as cobalt and phosphorus, adding nuance to its extraterrestrial origins. These were elements distributed unevenly in the solar system, and their particular ratios suggested the meteorite was very old, older than most rocks on Mars itself. That meant the stone carried a legacy predating the planet's surface history. It was not just older than Martian volcanoes or dry lakes, it might even be older than any sign of water flow on the planet. To touch such a stone, even through robotic instruments, felt like touching a time before Mars had its own identity, a moment when everything in the solar system was still taking shape. One side of the meteorite appeared smoother than the others, as though melted slightly more during entry. Scientists theorized that the stone may have tumbled in a particular orientation during descent, allowing one face to absorb more heat than the rest. That uneven melting created a kind of asymmetrical beauty, where one surface looked polished while another looked rugged and cratered. This imbalance was like a quiet reminder that even objects formed in star-heated chaos could carry imperfections shaped by chance, velocity, and the moment they met a planetary sky. The meteorite's edges were subtly rounded, likely from millions of years of microabrasion by windblown dust. Unlike Earth, where rain and vegetation soften stones, Mars shapes its rocks with patience and particles. Dust storms sweeping across the plains had slowly sanded the meteorite's sharper angles, smoothing them into gentle curves. These curves held the story of persistence, the way tiny grains, carried by persistent winds, had shaped something hard and ancient. Mars had sculpted this alien stone into part of its own landscape, adopting it through slow, subtle artistry. In some regions, reddish dust had fused lightly onto the metal, creating a speckled mosaic of silvers and reds. The blend of Martian and extraterrestrial material gave the stone an almost ceremonial appearance, as though the planet had draped it in its own colors. When scientists examined these fused dust patches, they learned about the chemical interactions between metal and Martian weathering agents. Even without water, reactions occurred, bonding elements together over vast stretches of time. This fusion was a quiet handshake between worlds, metal from the asteroid belt meeting iron-rich dust from a long-dried desert. The area surrounding the meteorite offered its own subtle clues. The soil beneath it was slightly more compacted, suggesting the stone may have once been warm enough to alter the ground on impact, if only briefly. Though the crater had long since disappeared, erased by winds and shifting sands, the faint compression remained. It was as though the ground still remembered the moment something heavy and hot struck it, then cooled, and became a permanent resident. This memory wasn't dramatic, it was soft and buried, an impression left in the planet's surface like a faint sigh. Intriguingly, small rock fragments nearby bore metallic traces, raising the possibility that tiny pieces of the meteorite had chipped off over millennia. These fragments were lighter, scattered further, and carried only faint hints of the original composition. They felt like echoes, small reminders of a larger presence. Their distribution hinted at how long the meteorite had been weathered by dust storms gentle enough to erode but not strong enough to displace the core mass. These little pieces added texture to the story, like footnotes that deepened the understanding of a main text. The meteorite also created a slight microclimate around itself, not in temperature, but in airflow. Standing as a small obstruction in the otherwise flat plain, it subtly redirected wind flows, causing eddies that piled dust unevenly. Over centuries, this pattern carved delicate arcs in the landscape, faint but visible under careful study. These arcs told of wind rhythms, where gusts slowed, where particles dropped, where currents swirled. The stone shaped its surroundings just by existing, a silent sculptor altering the canvas of the plane without moving at all. Some sensors detected traces of oxidation deep within cracks on the meteorite's surface. Even though Mars lacks abundant oxygen, tiny amounts in the atmosphere can react with metal over extraordinary periods. These reactions left faint streaks of darker material inside the stone's natural crevices, like lines on an aging face. They suggested that the meteorite, despite its durability, had not been untouched by Martian time. This aging was not decay but gentle transformation, just enough to remind scientists that even the strongest materials soften under eternity's gaze. Along one side, a narrow groove indicated that something, perhaps an ancient stone blown by wind, had once repeatedly struck the meteorite, carving a subtle mark over countless years. This groove was so delicate it might have been missed if not for the rover's close inspection. But once seen, it revealed the quiet violence of Martian weather, not dramatic storms, but persistent abrasion, nature working with gentle insistence rather than force. The groove became a measure of time, offering scale to the slow interactions that shaped the meteorite's life after landing. In rare moments, when the sun angled low, the metallic surface reflected light in a way that briefly illuminated the surrounding dust with a pale glow. This reflection created a soft aura, reminding observers that even on a planet famous for its muted colors and dim skies, moments of beauty could appear unexpectedly. The meteorite acted almost like a mirror, returning sunlight that was often swallowed by the red soil. These glimmers were fleeting, but each one felt like a gentle breath of brightness breathed into the stillness of the Martian afternoon. When scientists compared this meteorite to others found on Mars, they noticed similarities in composition but differences in size and preservation. Many meteorites on the planet degrade slowly due to exposure, but this one seemed uniquely well preserved. Perhaps it landed in a region where winds were less intense, or where dust accumulated often enough to shield it periodically. Its relative freshness made it valuable, offering clearer information about its origins without the ambiguity that heavy erosion brings. It was like finding a book whose pages had yellowed only slightly despite centuries of being left open. The meteorite also held thermal stories. Its dense metal cooled differently from the surrounding rocks, creating tiny temperature gradients that influenced dust movement around it. These microthermal effects persisted day after day, year after year, shaping patterns too subtle for humans to notice directly but measurable through instruments. The stone's temperature changed faster at dawn and slower at dusk, behaviors that, when charted, offered insights into how dense objects respond to Martian conditions. It was another layer of information carried quietly within its metallic weight. Scientists contemplated the meteorite's journey before it arrived on Mars. It likely originated deep within an asteroid's molten core, formed during the earliest epochs of the solar system when collisions were common and heat was plentiful. After being expelled, it drifted through space in a slow, cold meditation lasting millions or billions of years. Its arrival on Mars was not purposeful, merely a moment in an endless drift. Yet the fact that it survived intact, resting gently on a plane that would one day host a human-made explorer, felt like a story that had been waiting for an audience. The stone's presence also raised questions about how many meteorites still lie undiscovered on Mars. On Earth, water, plants, and geological activity bury or destroy these cosmic visitors. But on Mars, where erosion is slow and vegetation absent, meteorites can lie exposed almost indefinitely. This plane might hold dozens more, each with its own cosmic origin. The thought created a sense of richness in the barren landscape, a quiet treasure field of ancient metals, each one carrying a piece of a larger story written across the solar system. Some researchers wondered whether this meteorite had once been part of a larger piece that fragmented upon entry. If so, its missing companions might lie scattered across the plane, buried slightly or eroded to smaller shapes. Finding them could help reconstruct its original mass and structure. The idea turned the simple discovery into a puzzle, a gentle mystery stretching across kilometers of dust. Each potential fragment would carry part of the stone's earlier form, like scattered sentences from a poem waiting to be reassembled. The rover's gentle robotic arm brushed a small section clean to reveal the meteorite's interior gleam. The exposed metal had a crystalline texture, Widmanstatten patterns that hinted at extremely slow cooling within its parent body's core. These patterns, though faint, indicated the stone spent eons cooling at rates far slower than anything possible on planets. It was an inner structure shaped by cosmic patience, where atoms arranged themselves into long, delicate lines that could only form in deep, ancient stillness. Seeing these patterns on Mars felt like witnessing a message from before planets fully existed. As the rover moved around the meteorite, mapping its shape and composition, the stone seemed almost contemplative. There was no sound in the thin air, no rustle of leaves, no murmuring water, only the faint hum of machinery and the sigh of dust shifting under robotic wheels. In that quiet, the meteorite felt like a guest who had become a resident, content to spend eternity lying under the faint warmth of a distant sun. Its calm presence offered a sense of companionship to the lonely plane, as though even alien metal could share the silence. Scientists back on Earth watched the data stream in and felt a kind of reverence for the stone. Meteorites found on Earth often carry the signatures of our planet's weather and environment. But this one was untouched by rain, unweathered by oxygen-rich air, unmarked by biological presence. It felt raw, honest, unedited, cosmic origin preserved in its purest form. It allowed researchers to study the solar system's building blocks without the interference of Earth's dynamic processes. In this way, the stone became a quiet teacher, offering lessons in formation and endurance. Even as technology gathered everything measurable about the meteorite, something about it remained poetic, unquantifiable. Perhaps it was the way it rested so naturally in the Martian dust, as though it had adopted the planet's stillness. Perhaps it was the realization that countless other stones drift through space at this very moment, waiting for somewhere to land. Or perhaps it was simply the contrast between its ancient, fiery birth and its current peaceful state. The meteorite embodied both violence and serenity, held together in its cold metal heart. When the rover eventually rolled away, continuing its mission, the meteorite remained where it had always been, still, patient, and unchanged by the brief attention it received. It would continue lying there under rust-colored skies, weathering slowly, dreaming in metal. It would outlast machines, storms, and even the fleeting presence of future explorers. Its story would continue in silence, embedded in the plane like a punctuation mark in the long sentence of Martian history, a reminder that the universe leaves pieces of itself everywhere, waiting to be seen. And so, the unfamiliar stone on the plane became something more than a discovery. It became a bridge between worlds, a quiet traveler resting in red dust, carrying in its metallic depths the memory of ancient stars. Its presence softened the harshness of the landscape, turning the barren plain into a place where stories could settle gently. To find such an object in such an empty place was to remember that even in vast silence, the universe is full of whispers, waiting patiently, tenderly, to be heard. The moment scientists realized that the tiniest grains on Mars' dust, pebbles, and shy little mineral flakes were not just leftovers but messages, the entire rhythm of exploration softened into something more contemplative. These grains behaved like quiet storytellers, holding fragments of temperature shifts, whispers of ancient weather, and threads of old chemical dances. When researchers slowed down long enough to listen, they began to sense that the planet had not been silent at all. It had simply been speaking in its own delicate language, one that required patience more than instruments, and softness more than certainty. What surprised them most was how easily such microscopic hints could unsettle long-held assumptions. A tiny particle, no bigger than a grain of salt, carried chemical fingerprints suggesting it had once formed in the presence of flowing water, not trickling briefly but lingering long enough to shape the mineral's inner structure. Scientists stared at these grains under high-resolution microscopes, tracing lines like ancient scars, and felt a gentle push inside themselves, a push that said, "Perhaps you haven't been asking the right questions." It was the kind of push that made the night feel full of possibility, as though Mars had been waiting for someone to notice what it had been holding close for ages. Some particles revealed oxidation patterns that didn't match the expected timeline of the planet's climate. It was subtle, like a color slightly out of place, or a scent in the air that doesn't belong to the present season. Researchers found iron that had rusted not in the thin, dry Martian atmosphere of today, but in a past where moisture, perhaps even mild acidity, could linger. These details were nearly invisible, but they carried the weight of worlds. Each discovery made scientists pause in awe, recognizing that the smallest things often shift the largest ideas. In laboratories on Earth, where samples were preserved like fragile treasures, the dust behaved differently depending on how it was handled. Some grains released faint traces of trapped gases, as though exhaling after an eternity of silence. These gases, though minuscule, came in proportions that didn't fit neatly into old climate models. It was as if the planet was gently nudging researchers, encouraging them to rewrite chapters, re-evaluate equations, and soften their grip on certainty. The tiniest clues were rewriting the book, one sigh at a time. The more scientists examined these particles, the more they realized how complicated Mars' past must have been. The planet did not move from wet to dry in a single sweeping motion. It hesitated, oscillated, and shifted in a rhythm more intricate than once believed. Tiny mineral layers revealed cycles of dampness, drying, cooling, and sudden bursts of warmth, cycles so delicate that only the smallest grains could preserve them. These cycles suggested not a dying world, but a world caught in long, slow breaths. Some grains were unexpectedly magnetic, holding faint memory of ancient fields that had once wrapped the planet. This magnetic whisper suggested that Mars once possessed a stronger, more protective shield, capable of cradling delicate chemistry. That idea stirred something deep within researchers, because if the planet once had a warm interior, a protective field, and water that came and went in patient waves, then the early environment might have been far more comfortable than anyone dared imagine. A magnetic grain became a heartbeat from the past. Even more delicate were the carbon-based molecules detected in microscopic fissures. These weren't signs of life, at least not necessarily, but they showed complex interactions between rock, water, and atmospheric carbon dioxide over countless cycles. The molecules were labyrinths of possibility. Each twist in their structure hinted at reactions that required time, stability, and the gentle persistence of nature. They nudged researchers toward profound reconsiderations. Life might not have emerged, but the planet had certainly set the stage with quiet intention. Some grains shimmered with salts that only form through evaporation, meaning that water once pooled long enough to leave behind crystalline traces. These salts were like postcards from vanished lakes, carrying messages that said, yes, something once lingered here. The thought soothed researchers, making the Martian past feel less barren, more like a place that had once held warmth in the palm of its landscapes. When scientists heated certain particles to analyze them, they watched as tiny plumes of ancient vapor escaped into their instruments. These vapors acted like the mind of the rock opening for a moment, revealing memories long sealed within. The vapors contained ratios of hydrogen isotopes that implied the water on Mars had not vanished all at once. Instead, it slipped away slowly, like a deep sighing tide withdrawing from a once-living shore. Microscopic silica nodules added even more layers of mystery. On Earth, such nodules often form in the presence of microbial processes, though they can form abiotically as well. Their presence on Mars didn't claim anything definitive, but it made scientists tilt their heads, breathe deeper, and accept that some puzzles were better approached with gentle curiosity than with quick conclusions. This was the kind of puzzle that required sleepless nights not of stress, but of soft wondering. The fine dust also revealed that some areas experienced long-term groundwater movement beneath the surface. The grains captured subtle chemical gradients, suggesting that water once traveled through pores and cracks, leaving behind tiny signs of its journey. It was like finding footprints not on the surface, but hidden deep inside the soil itself. These discoveries suggested that Mars may have remained habitable below ground even after the surface turned hostile. At times, these grains contradicted each other, revealing different timelines or conflicting clues, as though Mars itself struggled to remember its own story consistently. But within these contradictions lay a kind of beauty, a reminder that worlds, like people, rarely hold simple histories. They shift, they fracture, they evolve, and they conceal parts of themselves even while offering others. Some particles held sulfur in forms that hinted at volcanic activity long after the planet was thought to have cooled. This extended volcanic timeline implied more heat beneath the crust than models predicted. More heat meant more potential for pockets of liquid water far longer into the planet's history than previously believed. And more lingering water meant more opportunities for chemistry to dance in the darkness. Tiny clay particles were among the most evocative. On Earth, clays often cradle organic molecules and preserve them for ages. On Mars, their presence pointed to stable, long-lasting interactions between water and rock, conditions that were neither violent nor brief, but patient. These Martian clays felt like gentle hands holding on to old secrets, waiting for someone to finally understand. Some grains had fractured in patterns that suggested freeze-thaw cycles, meaning the surface once experienced seasons not unlike cold desert landscapes on Earth. This made the planet feel more alive, more dynamic, and less frozen in its ancient fate. The cycles implied motion, rhythm, and time, conditions that nurture chemical flow and possibility. Occasionally, scientists encountered grains with coatings so thin they seemed like whispers wrapped around stone. These coatings formed through atmospheric reactions that required humidity and chemistry shifting together with quiet persistence. They were like soft blankets laid gently over the rock by a patient sky. Every coating told a story of air touching stone in a way that required delicacy. There were also tiny iron-rich spheres scattered among the dust, formed through gradual processes involving water or fluctuating acidity. The spheres were reminiscent of terrestrial concretions, which often develop in environments that support microbial life. Again, this wasn't evidence of biology, but it suggested that Mars had once hosted processes that mirrored those found in Earth's most intriguing environments. In some cases, grains contained trapped noble gases left over from ancient atmospheric conditions. These gases formed a timeline of the planet's breath across billions of years. Each noble gas ratio acted like a quiet clock, ticking through ages long before humans learned to listen. Such clocks, when interpreted carefully, suggested that Mars' atmosphere had been thicker, gentler, and far more vibrant in its youth. Other particles offered evidence of shock events, such as meteor impacts that had momentarily melted the surface. These shock features created microenvironments where heat, water, and minerals mixed in fleeting yet intense interactions. Such interactions can produce complex chemistry, transient but meaningful moments that hint at the planet's restless past. Some grains preserved signs of wind patterns that didn't match the current climate. Their alignment and erosion suggested that the Martian winds once blew from directions inconsistent with today's weather. This hinted at atmospheric shifts over immense timescales, making scientists wonder what forces sculpted these transitions and whether they contributed to the planet's gradual cooling. The tiniest particles hinted at glacial activity as well, minute abrasions and striations that resembled patterns formed by slow-moving ice. If glacier once crept across parts of Mars, even briefly, then the planet's climate variations were far more dramatic and textured than previously thought. Ice carries memories differently than water, carving histories into stone with a colder, more deliberate touch. Some grains contained perchlorates, which are often considered destructive to organic molecules. However, in certain conditions, these chemicals can also preserve or shield delicate compounds. Their dual role made researchers reconsider their assumptions about what could or could not survive on Mars' harsh surface. The planet seemed to enjoy contradicting expectations, offering clues wrapped in paradox. The grains also revealed fluctuations in pH levels across ancient environments. These subtle shifts implied that Mars hosted not just stagnant pools or dull plains but chemically diverse habitats, places where reactions varied, where energies shifted, and where complexity could quietly flourish. It painted a picture of a world not uniform but patchworked with countless microenvironments. Some of the smallest clues came from the distribution of the grains themselves. Their arrangement suggested that ancient water didn't just stand or trickle, it occasionally surged, carrying sediments across distances before settling them into patterns only persistent flow could create. These traces felt like the ghost of a river reaching across time, leaving behind a delicate signature. The last category of grains, perhaps the most poetic, contained tiny voids, microscopic hollows formed by trapped bubbles long gone. These bubbles once held the planet's air, perhaps even moisture. Their absence was like a soft ache, a gap in the stone that spoke of something that had once been present, warm and fleeting. In these empty spaces, scientists felt the quiet echo of a world that had lived many lives. All these clues, small enough to balance on the tip of a needle, convinced scientists that Mars was never a simple story. It was layered, intricate, conflicted, and full of quiet surprises. And in those surprises lay the reason why every researcher, no matter how certain they once were, found themselves reconsidering everything, not with frustration, but with wonder, like a listener finally realizing that a whisper carries more truth than a shout. Preservation matters because on a world as old and weathered as Mars, the past does not simply sit on the surface. Waiting to be read, it hides, curls inward, and buries itself beneath layers of dust and ancient frost. Scientists learned early that anything left exposed on the Martian plains is slowly scraped away by relentless winds, oxidized by an unforgiving atmosphere, or shattered by sudden temperature swings that crack stone like fragile glass. What survives does so not by chance, but because some quirk of environment wrapped around it with a protective patience. In those protected pockets, the planet's memory lingers, faint but intact, whispering across eons. Understanding why these pockets exist became as important as the clues they hold. When researchers examined sediment layers where minerals stacked themselves like pages in a cosmic diary, they realized that preservation was not just a matter of luck but of timing and conditions intersecting in delicate balance. A lakebed drying at precisely the right rate could lock chemical traces into layers that resisted erosion for billions of years. A volcanic ash fall settling calmly on damp soil could encapsulate organics before ultraviolet light destroyed them. These were not dramatic events, they were slow, almost gentle acts of geological protection, as though Mars had moments of unexpected tenderness, shielding its stories beneath mineral blankets. Some of the most well-preserved samples came from environments that seemed harsh at first glance: salt flats, evaporite deposits, and crusty plains where desiccation cracked the ground into mosaic patterns. Yet those salts acted like guardians, crystallizing around fragile molecules and shielding them from oxidation. On Earth, similar features preserve traces of ancient microbes long after everything else has vanished. Seeing parallels on Mars made scientists reconsider the influence of environments once dismissed as sterile. The very places thought least promising turned out to be quiet vaults, keeping secrets untouched. Preservation also mattered because the clues were delicate, not only small in size, but subtle in implication. The difference between an abiotic process and one influenced by life could lie in a very slight imbalance of isotopes, the faintest distortion of a molecular chain, or a trace of mineralogical layering that looked ordinary to untrained eyes. Without preservation, these differences collapse into chaos. But when the environment cradles them gently across time, scientists can study the subtle signatures and feel the weight of their meaning. In these faint variations, the conversation about life on Mars becomes more textured, more careful, and infinitely more profound. Even the planet's underground played a role in protecting its past. Beneath the surface, shielded from radiation and temperature extremes, delicate chemistry had time to settle into equilibrium. Porous rocks became slow, patient archives, letting fluids seep through over long spans, leaving behind chemical scrolls written in gradients of minerals. In some places, the subsurface remained untouched since ancient epochs, preserving the flavor of eras that the surface long forgot. These subterranean sanctuaries reminded scientists that Mars' past was not lost but simply hidden where gentle processes still ruled. Ice, too, proved to be a remarkable preserver. Glacial remnants stored bubbles of ancient atmosphere and froze sediments in place, halting the usual march of time. Ice holds memories differently than rock, less in composition and more in trapped context. Each pocket of frozen dust or gas was like a snapshot of a world that once breathed differently. On Earth, ice cores preserve entire climatic histories. On Mars, even a few preserved layers offered researchers the chance to imagine an entire chapter of environmental change. Frozen stories waited patiently beneath the silence. One of the most surprising preservers was volcanic glass. When molten rock cooled rapidly, it trapped within itself the chemical details of its surroundings. Some Martian glasses preserved water signatures without ever allowing them to evaporate. These glasses were like ancient photographs, capturing the environment's breath at the moment they formed. That breath could be read billions of years later, providing scientists with a rare clarity in a world where so much had faded. The existence of such glass forced explorers to appreciate ephemeral events that left behind durable artifacts. Preservation mattered in the context of organics most of all. Organic molecules are fragile, easily broken down by radiation, oxidants, and temperature cycles. Yet in certain sheltered environments, shadowed slopes, mineral-rich clays, ancient lakebeds that dried gently, organics survived long enough for modern instruments to detect. Some carbon chains were damaged, but enough structure remained to convey hints of past chemistry. Without preservation, the story of organic evolution on Mars would have been erased entirely. With preservation, even faint, damaged remains became messages worth decoding with extraordinary care. What fascinated researchers was how many types of preservation Mars offered despite its harshness. There were coatings on rocks formed by atmospheric interactions that sealed underlying layers. There were thin mineral films created by tiny trickles of water that shielded organics from radiation. There were sediments compacted so tightly that oxygen never penetrated deeply enough to alter them. Each mechanism acted like a different dialect of protection, and together they formed a chorus of geological compassion, as though the planet had found countless small ways to keep memories alive. Preservation also shaped the landscape in ways that guided exploration. Places where erosion exposed old layers became natural windows into the past, while other regions remained covered, preserving deeper time beneath untouched surfaces. These contrasts helped scientists map out Mars' history like archaeologists mapping an ancient civilization. They learned where the environment encouraged loss and where it encouraged protection. These insights helped guide rovers to locations where the most meaningful clues might still lie intact. The importance of preservation grew even more evident when scientists considered that many signs of ancient habitability are subtle. A change in pH over long periods, the presence of certain transition metals, or the delicate balance of isotopes might suggest conditions suitable for life without proving its existence. If these signs had been erased, there would be no conversation left, no speculation, no careful analysis, no quiet excitement. Preservation kept the conversation alive, allowing scientists to explore possibilities with depth and nuance. In some unexpected cases, meteor impacts contributed to preservation by burying sediments under ejecta layers. While impacts are violent, the layers they deposit can protect underlying materials from further erosion. What seemed like destruction became a gift, covering fragile deposits just deeply enough to save them from the planet's changing climate. This irony, the destructive act that preserves, made researchers appreciate the complex interplay of forces that guarded Mars' past. Dust, too, played its part. Though it often erases detail on the surface, in some cases it acts as a blanket, closing off exposed layers from further degradation. A dusting of fine particles might shield an organic signature from ultraviolet rays or insulate a surface from thermal stress. Over millions of years, this simple act of coverage becomes an act of preservation, a soft gesture from the planet to its oldest memories. Scientists also realized that the planet's thin atmosphere helped preserve some aspects of the past by slowing chemical reactions. With little humidity and little oxygen, reactions that might degrade organic compounds or minerals proceed much more slowly. Mars is a place where time moves differently, where decay takes longer, where stillness preserves rather than erases. The planet's austerity becomes its archive. Preservation mattered because without it, the planet would be nothing more than a red desert of forgotten possibilities. But with preservation, even the smallest discoveries, like a clay grain containing a trapped molecule, became transformative. Each clue was a doorway, leading researchers deeper into understanding what Mars once was and how it changed. These doorways expanded the imagination, inviting scientists to consider how life might have once fit into that environment, even if fleetingly. The rovers themselves became preservation-aware explorers. Instruments were designed to avoid contaminating samples, drills were engineered to retrieve materials from depths where conditions preserved ancient layers, and cameras captured textures indicating whether erosion or burial had shaped a rock's history. Every tool reflected the understanding that preservation wasn't just a convenience, it was the key to unlocking truth. Subsurface radar revealed buried structures, ancient river deltas, buried glacier, and sediment fans, each untouched by the erosive forces that reshaped the surface. These structures became gold mines of preserved history, almost like intact rooms in a ruined city. Scientists felt a thrill of reverence each time a buried landscape came into view, imagining the conditions under which it had remained untouched for eons. The planet's dryness, often seen as inhospitable, also acted as a perfect preserver of geological signatures. Without active plate tectonics or aggressive chemical cycling, Mars remained stable. It did not recycle its crust the way Earth does. Instead, it kept its oldest rocks near the surface. This stability allowed ancient terrains to sit quietly in the open, waiting for humans to finally arrive with instruments capable of understanding them. Preservation mattered because it enabled comparisons. Scientists could compare ancient clay with modern dust, ancient lakebed sediments with volcanic layers, and see how conditions evolved over time. These comparisons made the planet feel less distant, more like a place with a tangible narrative arc, one that could be followed from childhood to present day. The emotional impact of that coherence was profound. Even the absence of preservation in some regions carried meaning. Places where erosion stripped layers away revealed where the environment had been too harsh, too unstable, or too transformative to keep memories intact. These gaps taught researchers about the planet's energetic past, its storms, its shifts, its tempests. Understanding what was lost helped them appreciate even more what remained. In rare instances, Certain rocks showed signs of partial preservation, enough to reveal their age but not their original composition. These half-kept memories suggested complex histories involving incomplete protection. They were like faded pages in a book, still readable but blurred. This partial preservation reminded scientists that Mars' story was not a tidy one. It was filled with interruptions, losses, and fragments that required careful stitching together. In other cases, perfectly preserved microlayers held episodic records of climate transitions, wet periods followed by dryness, warmth followed by frost. Each thin band became a sentence, each cluster of bands a paragraph, building toward a larger chapter of environmental cycles. Reading these microlayers required immense patience, but the rewards were rich, offering insights unavailable anywhere else in the solar system. Ash layers from distant volcanic eruptions trapped organics beneath them, shielding them from destruction. Each layer served as a time marker, allowing scientists to determine not only what was preserved but when it had been captured. These volcanic timestamps provided anchors in a timeline that might otherwise feel dreamlike and unmoored. Preservation even showed up in unexpected forms like ancient hydrothermal deposits. These mineral-rich environments could encapsulate chemical activity in tight structures, preventing degradation. On Earth, such environments preserve evidence of early life. On Mars, they became promising windows into chemistry that might have leaned toward complexity. The more scientists studied preservation, the more they understood that Mars had not simply abandoned its past, it had safeguarded it in scattered vaults across the planet. These vaults were not arranged with intention, yet. They operated as if they were designed to keep the planet's secrets safe. And each time a rover or lander uncovered one, it felt like opening a gift left behind by a world still willing to share. Ultimately, preservation matters because it is the bridge between what once existed and what can be known today. On a planet where oceans vanished, atmospheres thinned, and surface conditions hardened into inhospitable deserts, preservation is the quiet miracle that keeps ancient truth alive. It is the gentle hand holding fragile stories against the erosive tide of time.